Okay, so you probably looked at ionic bonding, and now we're going to look at another kind of bonding, covalent bonding. Now, in ionic bonding, electrons are transferred from one atom to another, and it's always from a metal atom to a non-metal atom. Whereas in covalent bonds, a pair of electrons are shared. So electrons aren't transferred; they're shared. And it's always between two non-metal atoms. Okay, so example of ionic bonding, sodium chloride. I'm not going to talk about this because another video does that, but sodium is going to want to lose that electron. Chlorine wants to gain another electron in there to make that full outer shell, and you form ions, and that's what is happening here. Now, if you look at hydrogen, if you look at covalent bonding, let's look at hydrogen fluoride, Hf, which is a covalent compound. Hydrogen has got one electron. Now, hydrogen, and we'll draw it. It's got one electron in its shell. So it's going to want another electron so that it's got a full outer shell. So the first shell can fit two in it. Whereas fluorine has got two in the first shell, and it's got 7 in the second shell. So fluorine wants one more electron. So they both want one more electron. So neither one is going to give the other one an electron. But what they can do is they can come together and share like this. So if I just move that out, move the hydrogen over, we've now got, okay, so they share that pair of electrons. One of the electrons I've drawn as a cross, that's from the fluorine. One of the electrons is a dot from the hydrogen. They're sharing that pair of electrons. The fluorine thinks it's got 8 electrons in the shell full. The hydrogen, 2 electrons in the shell would be full. Now, normally when we do these diagrams, we don't show the inner shells because they don't do anything. It just makes the diagram look a bit confusing. You normally just show the outer shell that's involved in making the bond. And these are usually called dot cross diagrams for obvious reasons. And you show the electrons from one atom as dots and the other one as crosses. Okay, so if you think about another molecule, another covalent molecule, right, let's think of hydrogen. Okay, we know hydrogen goes around as H2. So let's draw one hydrogen like that, another hydrogen like that. So they've both got one electron in their outer shell. Now what they can do is come together. So I'm going to move that one over. And so they are now sharing a pair of electrons. So both hydrogen thinks that it's got 2 electrons in its outer shell, that it's full. So that's the hydrogen molecule. It's all very well drawing little dot cross diagrams like this, but these are representations of what's going on. Let's see what's really happening there. Is what you have is this pair of electrons. They're going to be shared between the 2 hydrogens. What do you think? What have we got in here? We've got a positive nucleus there, and we've got a positive nucleus there. Whereas the electrons shared between them, they are negatively charged. So there's going to be an attraction for the nuclei for those electrons between them, and that attraction inwards is what constitutes the covalent bond. Right, now covalent molecules exist as molecules. So here we've got a molecule of HF, so it's a hydrogen stuck to a chlorine. You could draw it like that. Frequently we draw covalent bonds as just lines, so that would be a molecule of hydrogen fluoride. And here we've got 2 hydrogens stuck together, forming a molecule of H2. Okay, so that's a very brief introduction to covalent bonds, and in the next video I'm going to show how to draw these dot cross diagrams.